Hello, my name is Samuel Adkins, and this is my final project demo for COT6402, analysis of algorithms. While I talk, I'm going to start the execution of my code, just because the brute force algorithm takes a good second to run. So our problem definition, the one I chose, is the longest palindrome, where the input is a string of length n that contains only alphanumeric characters, and we are going to find the longest palindrome substring in the given array or a string, and output the start index of the palindrome and the length of that max long palindrome. Here you can see return start index max length. The three algorithms we chose: algorithm 1 is brute force, algorithm 2 dynamic programming, algorithm 3 manager algorithm. So first we import our libraries. We generate our random string with this method. We define each of our algorithms, and we define the run experiment method, which takes in an algorithm, a string, and we define the repetition as 5. That way we run a test for each input size. We test the same input string, and we average those runtimes to get us a accurate value. Here we define the input sizes we're going to use, our algorithm runtime arrays, and then for each input size we generate the input string, and we use this same input string for each of the tests. That way all algorithms are tested on the same string to make it fair, I guess you could say. And then when that's done, we can go through the plots. What else? We know that the algorithm 1 should be O(n) cubed complexity. Dynamic programming is polynomial or n squared complexity, and the manager algorithm will be O(n) complexity. This does take a second to run. Perhaps I should have started it before. It'll take, if you run the source code, I'm also providing a Google Colab link. If you run in there, it'll take a little longer to run. It should almost be done. I guess I could go over the results. Actually, we can go over the results that are in the report, which first I graphed it real quickly using matplotlib library, and here we print out the algorithm runtimes. These are the average ones, and then we write code. We calculate the predicted runtimes after using the empirical runtimes to find the constant values C1, C2, and C3. And then after hard coding in our calculations, we can plot the empirical runtimes against the predicted runtimes for each algorithm, and everything aligns to our expectations, where algorithm 1 is a cubic growth, algorithm 2 is more of a squared growth, and algorithm 3 is linear growth, where the complexity was just big O(n). And here's them plotted all against each other. Is that done running yet? No. Hopefully it will be done running soon. I think it actually took right around 5 or 6 minutes. Okay, now that that is done running, I probably trimmed the video right there. It took 6 minutes to run, which would be a little over the length. We can use this cell to see that those runtimes are follow the conclusion in the report and the hard-coded curves here from the calculated values. And yeah, that's the demo of my longest palindrome project. Thank you.